Dream to become the next Sir Isaac Newton or Albert Einstein? Learn calculus from Refath Bari, aka 800/800 guy, is teaching calculus this year. Watch his videos to achieve your dream.
What's up, folks? This is the 5th calculus lecture, and this is what we have to prove. We have to prove that the following two statements are equal. A union B difference C is equal to A union B difference C difference A. So in set theory, when we want to prove that two things are equal to each other, in particular when we want to prove two sets are equal to each other, we have to prove the following. We have to show that the left side is a subset of the right side, and we have to show that the right side is a subset of the left side. When we do that, we prove that they're equal to each other. So let's do that. So the first thing we want to do is prove that the left-hand side is a subset of the right-hand side. We want to do that because that means all the elements in the left-hand side are inside all the elements in the right-hand side. So let's go ahead and prove this. How do we prove that this is a subset of that? Well, let's assume that there's an element x inside, located in this left-hand side set. So x is an element of this set. Alright, so if x is an element of A union B difference C, we know that union means or, right? So that means x is either an element of A, or the other case is x is an element of B difference C. B difference C. Good. So we know that x is an element of A, right? If x is an element of A, it has to be an element of the right-hand side. Why? Because you can see we're including A right here, A union B. So that means because x is an element of A, x must be an element of A union B difference C difference A. Okay, so what if x is, what if we take the second case, that x is an element of B difference C? Well, even if x is an element of B difference C, what does that even mean? That means x is an element of B, but it's not an element of C. Right, and, this is an and. So both of the conditions are true. So because x is an element of B, once again we know x must be an element of the right-hand side, because you can see B included here. So thus we can conclude that once again x is an element of A union B difference C difference A. Okay, so we've shown that if x is an element of A, it's an element of the right-hand side. If x is an element of B difference C, it's also an element of the right-hand side. So what are we going to do now? We're going to combine these two statements. If x is an element of A union B difference C, if x is an element of A union B difference C, then therefore x must also be an element of the right hand side. Let me just copy that down. But we are not done yet. You might think we're done, but we're only halfway there, because we have proved that the left hand side is a subset of the right hand side, but we have not proved vice versa. We have not shown all the elements of the right hand side in the right hand set are in the left hand side. So let's go ahead and prove that. Okay, so this is the second thing we want to prove. We want to show that, what is this? A union B difference C difference A is a subset of A union B difference C. You didn't write it? Yeah. Okay, so how do we show this? Well, exact same method. Let's pretend there's an element x inside this left-hand side. So let x be an element of the left-hand side. So naturally, by using the definition of the difference of sets, which I covered in our last video, go ahead and watch that if you didn't already, we can conclude that x must be an element of A union B, and it must not be an element of C difference A. Now, notice the definition of the difference of sets tells us x must be an element of A union B. You see that A union B is right here, right? So that means x must be an element of the left-hand side, A union B difference C. And thus we have just proved vice versa. We have proved that the right-hand side is a subset of the left-hand side. And now we can combine these two subset statements to get the final answer, which is that A union B difference C is equal to A union B difference C difference A. And so we have proved this set theory statement. So thank you for watching. We'll see you next time.
Subscribe to Bari Science Lab to fall in love with math and science.